Hello, in this video we will do exercise 7, page 33. Complete the following equalities. We have 35, it becomes 5. It becomes smaller, so we divide 35 by 7. So here we divide the fraction by 7. So we divide also 42 by 7 and we get 6. Now 5 becomes 20. It becomes bigger. So we multiply the fraction by 4 because 5 times 4 is equal to 20. So here we have to multiply the 6 by 4. 6 times 4 is equal to 24. Now 24 becomes 240. So here what we do, we multiply the fraction by 10. It becomes bigger and we multiply 24 by 10. So we multiply 20 also by 10 and we get 200. Here 60 becomes 20, so we divide, it becomes smaller. So we divide the fraction by 3. 20 times what equal to 60? It is 3. So we divide 48 by 3 and we get 19. Now here, look, 19. Can 19 becomes 8? No. So here we have to turn to this fraction 48. How becomes 8? We multiply we divide the number by 6 to get 8. So here we have to divide 60 by 8. We divide 60 by 8. Sorry, by 6. We divide 60 by 6 and we get 10. Now 10 how becomes 30? We multiply it by 3. So we have to multiply the 8 by 3. Multiply 8 by 3. We get 24. Now 30 becomes 10. So we divide the fraction by 3. So here we have to divide 24 by 3. And we get 8. Now 8 how becomes 48? 8 times 6. So we multiply the fraction by 6. So here we multiply 10 by 8 by 6 and we get 60. And we get 60. So 10 times 6 is equal to 60. Now 48 becomes 12. How becomes 48 12? What we do? We divide 48 by, we think 12 times what equals to 48 times 4. So we divide 48 by 4. So here we have to divide 60 by 4. When we divide 60 by 4, we get 15. Do you remember that 15 times 4 is equal to 60? Now 15 now becomes 5. we divide it by 3. So here we have to divide 12 by 3. Divide 12 by 3. We get 4. Now page 34, exercise 11. There are 550 students in a school, among which 250 are girls. What is the irreducible fraction that represents the number of girls in this school? Look, here we have the total. Total is 550 and the number of girls is 250. So how to find the fraction representing the number of girls? It is the number of girls over the total. So it is 250 over 550. Now, to get an irreducible fraction, we can use two methods, or successive divisions, or we find the GCD and we divide by the GCD. Here, we can do the successive divisions. So we can divide this fraction by 10. We get 25 over 55. And now we can divide by 5 because the ones digits are 5. And 25 divided by 5 is 5. 55 divided by 5 is 11. So the irreducible fraction that represents the number of girls is 5/11. Now give the irreducible fraction that represents the boys in this school. But we don't know the number of boys. Let's find the number of boys. We have to subtract the total. Subtract the number of girls from the total. 550 minus 250 is equal to 300. Now we can find the fraction. It is the number of boys over the total, 300 over 550. And now we have to reduce this fraction. We can reduce this fraction using successive divisions. So we can divide this fraction by 10 because one's digit in the numerator and the denominator is 0. When we divide it by 10, we get 30 over 55. And here we have 0 and 5 in the ones digits. So we can divide the fraction by 5. 30 divided by 5, 6. 55 divided by 5, 11. So the irreducible fractions, a fraction of boys in this school is 6/11. Now exercise 14, page 34. Consider the fraction A, 28 over 42, B, 110 over 275, and C, 16 over 25. Reduce the fraction A by the GCD method. So we have to find the GCD of the numerator and the denominator, and we divide by this GCD. We decompose 28, we get 28 is equal to 7 times 2 to the power 2. And we decompose 42, we get 42 is equal to 7 times 2 times 3. And the GCD, we take the common factors with the smallest exponent. So it is 7 times 2. We take 2, not 2 to the power 2, because we take the common with the smallest exponent. And the GCD is 14. 7 times 2, which is 14. Now we have to divide the fraction by 14, 28 divide by 14 and 42 divide by 14. So when we divide by 14, 28 by 14, what we get to know directly the answer, we can know from this decomposed form. How to know? We take 7 and 2. It left what? Look here, we take 7 and 1, 2. It left other 2. So the answer is 2. And here in the GCT, we take 7 and 2. It left 3. So the answer is 3. And the irreducible fraction is 2/3. Now reduce the fraction b by the method of successive divisions. We have to think of common divisor of the numerator and the denominator, and we divide by it. Here we have 0 in the ones digit and 5, so we can divide the fraction by 5, and we get 11 over we divide 110 by 5, we get, divide this by 5, 20, 20, 22. And when we divide 275 by 5, we get 55. Now we can divide this fraction by 11. 22 divided by 11 is equal to 2, and 55 divided by 11 is equal to 5. So we get 2/5. Now show that the fraction c is irreducible. Look at c. We have 16 and 25. How we know if a fraction is irreducible? The numerator and the denominator should be relatively prime. It means they don't have a common divisor other than 1. Look at 16 and 25. Do they have a common divisor other than 1? No, we think about 2, 3, 4, 5, 6. No common divisor other than 1, so they are relatively prime. We say that 16 and 25 are relatively prime, so the fraction c is irreducible. Thank you.